Hey everyone, I'm back finally with a new video. Today we're just going to analyze this malicious document. I'm going to show you some tips, tricks, tools, all of the above, hopefully to assist some of your learning. You don't need Microsoft Office or Word. All you need is Remnux and some time to learn how to do some of this stuff. So follow me over to my Remnux machine and let's get started. So I have this sample. I've gained it from a class that I've taken, and it's not a live sample, but if it was, this is how I'd walk through some of the stuff I'm going to show you. First thing and foremost, I'm actually going to figure out what type of sample this is by running file against it. I want to confirm that it actually is a Microsoft Word document because I can't trust necessarily what the extension says. Another tool that I would actually run against this just to get a little more confirmation and maybe a few more details would be TRID. And both of these are just verification of the file format and kind of knowing what I'm about to deal with. So TRID tells us that this is a Microsoft Word document, confirms that. It tells us that it's OLE 2, it's the older version, and so we know that OLE 2 is how VBA macros are embedded within Microsoft Word documents. And just a tip for you, OLE 2 and CDV2 mean the exact same thing. So there you go. Now, if you're pressed for time, the first tool that I actually want to show you is OLE VBA. And the reason being is because it runs a bit of automation against this document and gives us all the details that we need very quickly in case we're pressed for time. So if you run that, it will confirm the file that I kind of mentioned in the type. It actually will give you the VBA macro that's in there if there is one. And we'll get into more details about this here in a second. If you scroll down to the bottom, you actually get to see a few of the keywords, some description of what they are, and you'll get a quick synopsis of maybe what's going on in this document and if you need to investigate further. Now, in our case, we do want to investigate further. So I'm going to show you your best friend for today, and it's going to be OLE Dump. OLE Dump is another tool. This tool is actually created by Didier Stevens, and he's going to be the author of most of the tools we're going to be used today because they're just so well done. So first and foremost, if I run OLE dump against checkbox.doc, what it does is it breaks down the document into various streams, which are numbered on the left-hand side. It identifies if there's any macros, specifically with a capital M. It gives us the size of the data in the stream and then the stream name that it's calling it. Now, if I run OLE dump with attack I, it actually gives us a little more information, pretty much the same stuff, but the one thing you'll notice is this new column, which has a 0 plus 163. And really quickly, what this means is it actually breaks down the size of what's in that stream. So the 0 in this scenario stands for the compiled P code. And I'll explain that here in just a second. And the second number is actually the compressed source code. So P code is VBA essentially compiled and compressed into the Word document. And the reason this is a 0 here for this specific sample is because the technique being used is called VBA purging. Basically, a malicious actor was trying to get rid of the P code and only have the compressed source code, and it will still run whatever they wanted it to run. It's just a technique that actors use. If you'd like, I suggest looking that up on your best friend and your friendly neighborhood Google. But for our purposes, we want to see what's in that stream. So in order to find out what the macro is, you're going to run OLE dump again against the same stuff. This time we're actually going to provide a lowercase s with the argument of 9 because we're dealing with stream 9 because it has the capital M and it had the macro that we're mostly interested in. And because I know that this is compressed source code, in order to decompress it and see it a little cleaner, I'm going to give it a attack V. And so we actually see the exact same VBA that OLE VBA gave us. So again, we're seeing power. If I scroll up, I just want to show, oh, I cleared it, my bad. Anyways, trust my word. We're seeing PowerShell. It's getting executed with a hidden window, and it's getting a encoded command from whatever's in user 1, checkbox 1, whatever. Encoded commands in PowerShell are typically base 64, so we're going to need to look for something that's base 64 encoded. And specifically, we're going to look through user form 1 and try and identify what that might be. So if I come back and look at what my Ole dump output was, we want to see streams that have user form 1 in it. So we see stream 5, 6, 7, 8, etc. Okay, so we want to actually look for anything that's base 64, and I'm actually going to give this a tag D, because what it will do is dump whatever's in that stream for us. So that doesn't look like base 64 for stream 5. If I run stream 6, that doesn't look like base 64. And if I just run this again against stream 7, as I'm just going down the list here of all the things with user form 1 in it, that looks like base 64. Okay, so we've kind of found out what stream, and I'm gonna give you the output again real quick. So we've identified that stream 7 has base 64 encoded in it, and that's kind of where we want to pivot to next. So this macro, again, if I want to highlight what exactly it was doing, I'll just showcase it. It looked into, it's going to take whatever's in user form 1 and do stuff with it within PowerShell. Okay, so now that we know that, we want to actually dump stream 7, and we want to actually give it to our next tool that we're going to utilize, which is base 64 dump. And if I give that there, let's go ahead and pipe that just a more. Okay, so we see that base 64 dump created a stream that has that encoded PowerShell in it, and the PowerShell decoded looks like there's stuff in there. Okay, well, one thing I'm noticing, and this is something that you probably just get through experience, and I had to ask the question initially, so now I'm teaching you so you don't have to ask the question. But if you see dots like this, typically from something that's encoded and then decoded, that usually represents that it might be UTF. And the way to do UTF conversion is through base 64 dump. So we can actually say that we want to provide stream 1 here, and that's this stream, because base 64 acts like Ole dump and breaks everything down in streams. So we want to take stream 1 here, and in order to convert something from UTF, you're going to actually use tac T within base 64, and then I'm just going to say give it UTF 16, and I'll pipe that again more here. Okay, so that looks like it probably converted everything, and instead of me just printing it out to the screen, let's give it a file. Let's just send it to a file, and we know that this is PowerShell, so I'm just going to do checkbox1.ps1, and then I'm going to open this up so we can actually look at this. Give it a second. Okay, so we see there's new object, IO memory stream, and we see more base 64. Okay, so we have this saved, and we see also that there's this gzip stream, and it's decompressing it. Okay, so our next move here is we probably want to see what's in this base 64 stuff. So what I would do is run base 64 dump. Oh, got to spell it correctly. Base 64 dump against our newly created PowerShell file and see what it does. And as I mentioned, base 64 kind of works like Ole dump, and it creates streams. So we see, all right, it has the stream of the encoded PowerShell, which is matching up to kind of the first few bytes we see there as well. So we probably want to dump that, but the only thing that might be different is this is getting converted, and then it looks like piped to gzip stream, so we may need to unzip whatever's in that. Okay, so if I dump that, we want to take stream 3 and dump, but we want to pipe that over to gunzip, and then maybe save that to a new PowerShell file. Sure. Okay. That seemed to be okay. And let's check that PowerShell file. So I'm opening it up. Okay. So my theory was correct. So before I continue, I'll take a step back here and summarize what we've done so far. So we had a malicious VBA embedded document, and that called some PowerShell within some value in that document. And that PowerShell was base64 encoded, so we decoded it. Then we had more PowerShell, which is within here. So we wanted to decode that, but we noticed that that PowerShell is probably getting sent over to this new object. And just so you know, IEX is a trick within PowerShell that stands for invoke expression. So it's going to take whatever's in this stream, and we see the gzip decompress. So that's just a way to zip up the data. So what we did is we took the PowerShell similar to the first time and dumped it out with base64 dump, and then we piped it over to gunzip or gunzip, however you say it, and saved that to a new file. And our new file that we have is checkbox2.ps1. And it looks like it's more PowerShell, which we kind of anticipated. So as I scroll through here, I'm seeing that there's more PowerShell right here. So we probably need to do something with that. Another thing I noticed is BXOR and probably a key. So if you don't know, this probably stands for byte XOR, which it's going to rotate bytes according to this key. It's basically trying to obfuscate itself. And if I keep looking here, we see this var VA, and then it's going to do stuff. What else? Oh, virtual alloc, kernel 32. Okay, that sounds like memory stuff to me because from experience, virtual alloc basically is carving out a portion in memory of something. So it's probably going to take this and pipe this to memory, if I had to guess. But we probably want to see what that looks like. So let's go back to our trusty tool set. All right, so from this point on, let me clear this out. Okay, so we're going to run base64 dump against checkbox 2 this time and just see what happens. Okay, so we have a ton of streams here, and it's probably because I did not specify how many bytes that we care about. So one thing with base64 dump that we can do is give it a tac n, and let's just say we want more than, let's say 10 bytes, right? We want to identify only streams that have 10 bytes. The only reason I picked that is because I saw 4 and 8 and then 12, so yeah. I just want to eliminate all the 4 and 8 stuff because that's not things we're interested in. So what I do see here is, I would say this stream 2, because this is, we already know that that exists. So we're probably going to want to dump that again, right? But the trick and the difference here is, last time we knew, if I come back, we were taking base64 and giving it to gzip and decompressing it. So we were unzipping this base64 stuff, which essentially was this script. But this time when we're taking whatever's here, we're storing it, this script is storing it in var code, and then it's XORing var code. And then I see var code within all that buffer stuff. So it's probably not another PowerShell file, if I had to guess. And if you know anything about malware analysis, memory analysis, any of that stuff, you'll know that virtual alloc is used to pipe memory through. And if you don't know, now you know. But basically, virtual alloc with some kind of XOR base64 stuff tells me that there's data that it wants to do. So it's probably not sending over another PowerShell file, so we probably want to see what it is doing. Okay, so I want to grab this stream 2. I want to dump it, I believe. Excuse me. And another tool that we can use is translate pi, and this is built into Remnux. And the reason we're using that is because it will actually do the work for us to XOR this this base 64. And we know that it has a key of 35, so the way we provide that is byte, I think it's this. Yeah, okay. I think that's correct. Okay. Well, let's go ahead and try that. Okay, well, that's not anything I know, but this looks okay. So this might be, I see an IP address. Okay, this might be like binary, like shellcode maybe. So I'm gonna actually pipe this over to maybe checkbox.bin. Okay, and maybe I run and just see if it actually confirms that. It just says data. And maybe I run trit against that and see what this does, if it tells us anything else. It says unknown file. Okay, so maybe this is shellcode. And the way we might want to figure out if it's shellcode is we could run one more tool, which is scdbgc, against this. And this is basically a shellcode emulator or that's built in within Remnux that we can kind of run and see if there actually is shellcode going. So I'm actually going to try this out right now, and I'm going to, I believe /f is how you specify the file, and I think that's all I need. Okay, let's see what happens. I might have messed something up, and if so, we'll figure it out. Oh, okay. So it didn't do exactly what I wanted it to do, but it did run. And we see that it has this API called load library, internet open. It's connecting to that server over this port. Okay, so we've seen it's doing something. I think if you provide this, it will run. I don't remember the arguments, exactly what the meaning is, but just trust me on this one. I might have to Google it to confirm, but let's just see if it does anything else. Okay, yeah, I forgot what this is. I'll have to maybe add this in the notes or something. But I believe it just runs until, like, it doesn't stop if you add the /s and -1. It'll allow it to kind of keep going until you close out the session. But the reason I did that is because I wanted to see if it did any more information, which it does. It calls the same stuff, but we see the user agent that's being used within this HTTP request. And that was important because we saw it within this shellcode up here, or whatever this hoopla stuff was. But we wanted to see if we could find that again. And this is going to still run, so let me just close that out here in a second. Okay. So we've seen a bunch of stuff now. And this is going to be doing something. It's probably trying to grab something from the internet. It looks like it's doing all the API requests to grab some additional malicious whatever from the internet and do stuff with it. But to take a step back for us, this all started with a document that had some VBA in it. And now if you only ran the OLE VBA initially, you wouldn't have got all this. So we had to take the VBA and identify what it was doing, which it called PowerShell. And PowerShell referenced actual data within that document, which was base64 encoded. And then we had more base64 encoding, so we had to get that out. But there was a trick there because that base64 encoding was zipped, so we had to unzip it, which gave us a secondary file, which we called checkbox2.ps1. And then from there, we kind of just looked at some stuff. We noticed this BXOR 35. We noticed more base64. We wanted to see what this was getting saved as. We see it saved as var code. If we look quickly in the document, var code is not used anywhere but the encode or the XOR piece, and then as a buffer and in the runtime. And before the buffer, we kind of scrolled through and we saw a few things that stuck out. Kernel 32 DLL, virtual alloc, all stuff to kind of take advantage of carving out some memory and doing something. And we confirmed all of this by running a scdbgc, which is a shell or an emulator for shellcode or binary code and stuff we don't really know. So the reason we ran that was to see if this binary was going to actually try and do anything, and it did. So hopefully you've kind of gained some insight into how just one little document can turn into shellcode reaching out to the internet trying to do more malicious things, which thankfully we don't see because this was not connected to the internet within my lab environment. But if you have any questions or you want to know more, please feel free to comment them and I will do my best to respond. I'd like to do some more malware analysis videos on doc files and Excel files if that interests you. And if you like this video, do the whole YouTube thing, like, subscribe, all that fun stuff. But most importantly, thanks for watching. Hopefully you learned something and we'll see you on the next video. Everyone take care. Bye.